Um, Hi, I hope you have a nice weekend. Um, let's get started. Hopefully we will finish this probability today, and it will be later when you maybe you have finished. I will release quiz 2, which you can do it on your own pace. It's not credit bearing, same as quiz 1. You can do a multiple choice question when you like. I mean, it's not credit bearing option. But later, starting from Wednesday, I will give you the assignment 1, which cover material up to today's, up to the probability. You were given 2 weeks to do it. So if I finish today, then you still have extra 3 more days. So it will be 17 days. But I think it's sufficient for you to do. The assignment look like this. Later you will see just like some question on some statistics, finding covariance, correlation, and ask you Excel how to operate, and then some probability problems. Okay, so you will be given like half a month to do it, 15 days more or less. Because we're supposed to finish everything. I think it should be time-wise should be enough for you to finish everything. So let's get ahead because we want to finish the whole chapter today. So the idea of this chapter again is to give you the foundation of probability, so that it'll be useful, build the foundation for you for the next chapter. Random variable by itself is already very useful if you learn engineering or you try to model some uncertain phenomenon. Random variable is already by itself is useful, but of course we use it when we learn how to do estimation, how to do prediction, how to do regression. All of the second half of the course is based on this. And now let's review what we have learned. Probably just a reminder because it has been there, right? Because of first is we define the frequency list approach, or the classical way of defining probability, which is if something can be repeated many times, right? And you can estimate the probability by thinking that you repeat many times, the ratio of things that happen over how many times you repeat, right? It's a fraction. So it must be from 0 to 1, right? Negative probability has no meaning in that context. Probability more than 1 has no meaning because 1 is already always happened, right? Do note that this definition assume that you have the knowledge of what are possible outcomes, okay? It is always not this outcome will arise, surprise you, but rather why this, not the others, okay? It's always, this is considered in theory is possible, okay? It's not surprise in theory, it's surprise in realization that actually happened, okay? And then we learn how we define some operation on set, right? Is union, intersect, complement. In daily language, intersect means or, union means or, complement means not. Okay, this is the same as a logic. If you have a logic, the same thing. Okay, there's nothing very new here. And we also learned some special event that will be useful when we define axioms, right? Mutually exclusive means they can't happen at the same time, right? Say you are in CHK and at home it's mutually exclusive, right? Unless you consider CHK as a home, right? Otherwise, these are the place you cannot simultaneously at the same time, right? And exhaustive means that it can't be all false, right? At least one of them is true. Okay, cannot be all false, right? Mutual exclusive cannot be all true. Mutual exclusive cannot be all false, right? One of them must be true, right? Say happy and not happy, right? It's one way or the other. And the final one is so special, it's called partition. And that is called mutually exclusive, exhaustive. Is one and the only one must be true. Okay. And once we have that, we can basically define OS probability by 3 axioms, right? First one is anything must be from 0 to 1, right? Any event you consider must be 0 to 1. And the sample space must be 1, so these are just normalization. There's nothing deep in this. We're supposed to change it to not 1 to 2 is everything goes through, no problem. So the only thing have real content or has substantial content is this one, right? If you have event that is consists of a finite collection of mutual exclusive event, then it just the whole is sum of its parts. Probability of event will be sum of all the event of outcomes if they are mutually exclusive, right? And of course, if n is finite, then it's nothing, not surprise you, right? It's just like if whole thing you divide into multiple parts, then it is where it is a real if it's not whole is not sum of its part, right? But it's not so straightforward. That's why mathematicians actually spend around 300 years to figure out that, okay, actually this would hold when you're in extended infinity. Why you care about that? Because infinity is needed when you're talking about continuous random variable or continuous stuff, right? If things is realized 1, 2, 3, 4, 5, that's fine, right? But if you think about when you need calculus, when you need continuous, right? Say temperature is like from 0 to 100, say suppose, right? But any number in between is fine, right? There's continuous possibility, infinite many possibility between 0 to 100. In that case, we really need this kind of definition. But of course, if everything is finite, it's also fine. I mean, that's how we learn in the high school, right? But when you learn to college, then you understand that continuous, when you learn a bell curve, those kind of stuff actually require continuous. That require this definition. But we're not math class, so we just say, okay, it holds finite, go to infinite. Yeah, no problem. Just take it easy. Okay. Now, with these 3 axioms and actually derive all the formula you learn in high school, right? This is the complement rule also you learn in the high school as well, right? If you want to calculate event of something that's difficult to calculate, you can calculate complement and -1 from that, then we're done, right? That is the way we do in high school if you learn probability, right? And these are the other rule that also you learn in high school, right? If I have a union or intercept, whatever you want to do, you can add that together minus if you have union, then you subtract the complement. If the union, you subtract intercept, right? If intercept, subtract the union, right? Just to remind you, this formula is the famous formula you learned in kindergarten, right? If you calculate this area to circle intercept, right? This area, you take the red circle plus the purple circle minus the pink overlapping area because you double count it, right? So that's how you do the calculation, right? And you also learn this total probability rule, right? It's A with B and A without B, right? The idea is even more simple. We call them cut-kicking ceremony, right? If the red circle is the part with the light red and with the pink, right? The light red is the part A without B. The part pink is the A with B, right? A is A with B and A without B. That's it, right? There's nothing very special here. Okay. And you can do a partition, right? It's B will be B with A1 up to AN, right? If a partition, right? Remember, partition is what? Mutually exclusive, exhaustive. So one and only one would happen to be true. Okay. And lastly, we talk about odd ratio. And of course, if you know how people think about probability or how to measure likelihood or certain thing, in the old days, people think about likelihood, right? Normalized to 0 to 1 is something modern, right? Because people are able to do fraction in old days, right? Compare 1 to 1 or 1 to 2 or those kind of thing. You look at classical text, people able to do fraction, ratio, integer, right? Doing decimal or doing something more real numbers, something is not understood later in the stage of history. So people in the old day learn odd ratio. And that's why in the gambling, people still use odd ratio, right? Just to remind you this example, because people ask me at the end of the class. So, if you roll a die, okay, there's 6 outcomes. If it's fair, each outcome will be equally likely, right? So if the what's the odd ratio in favor of 6 will be, you take a probability and 1 minus the probability, right? 1/6 over 1 minus 1/6 is 1 to 5, right? So out of 6 times, right? 5 times you lose, 1 time you win. This 1 to 5, right? That's what it means, right? And the question is saying, okay, if you go to a casino, the casino is fair, okay? Then what is the odd, right? What it means is the casino is fair. If you bet $1 for having 6, okay, and you lose the $1 if not 6, how much is the win if 6 comes out? Okay, the answer should be 5. The reason is you win if on average every 6 times you win 1 time, you should win $5. The other 5 times you should lose $1. So then even out. Okay. So why we need that? Because that means that if you go to casino, look at the betting, then you can convert it back, look at the probability. And it's useful when you go to the casino online, they can bet everything, right? They can bet whether tomorrow have rainfall, okay? Whether 10 years time there will be earthquake, or 100 years time maybe there is a alien comes in, whatever you can bet. I mean, there's every crazy thing you can bet, right? So there, I mean, you can do whatever you like, but I mean, but you can't get probability, right? Because remember, the classical definition of probability have to rely on random experiment, right? But if you don't have random experiment, then how can you estimate probability? Okay, from the odd ratio, the market, utilize the market, can go back, right? And we only need 3 axioms. As long as you satisfy 3 axioms, then we're fine. How can we make sure satisfy 3 axioms? I mean, that with the rule, and then actually, as long as the system is consistent, then everything is fine. Okay, so, and now that is the end of what we have covered last week. Now we come to a more exciting part, and that is called conditional probability and Bayes rule. And why this is important? Because this is related to learning, or human learning, right? Or if you want, machine learning as well. There's nothing human special, right? Machine learning also the same, okay? And this is how people update information, okay? This is how later you will see learn important rule called Bayes rule. That's how we learn. We have some knowledge about what might happen, and the knowledge will tell us how you learn, and this is how in scientific discovery being done or machine learning being done. Okay, of course, machine learning can be more complicated, but the underlying is following what we have done here, right? Because under the truth is never known, right? Then you keep updating probability, right? Even science is like this, right? Because we never know what's true for sure, right? But we keep collecting evidence, we keep updating, and then what we know today as a science is the collection wisdom of what the information has is the system of probability, right? Right? We say, right, the sun rises from the east, right? This is, we repeat many times, and we believe that is probability of 9999, this is true, right? Even 1 is still some probability there. But anyway, we don't want to discuss the philosophy. But everything we have in our knowledge system is basically can be explained by this, okay? But we start from the basic. What is conditional probability here? Okay, but we learn thing is like this: is we have something we know, and then we want to update. Okay, so the idea they let me start with definition, and then we will explain why it's the case. Okay, we'll define this probability A if B is happen to be true is what? Updated by looking at the intercept over the probability B. Okay, why is the case? first is B is true, means that A intercept B complement is not relevant, right? Because B is true. B complement is not true, right? Because B and B complement are mutually exclusive, right? If B is true, B complement cannot be true. And why you have to dy? Because probability is from 0 to 1. You have to normalize it, okay? But it's still very abstract. Why we need to do that, right? One example would be like this. Okay, let me draw a picture then to visualize why we need that. Okay, you often need that actually in a military situation. Okay, now consider a somewhat politically incorrect situation, right? Imagine here, this is a map of Afghanistan. Okay, after 9/11, US want to bomb Bin Laden, right? Probably know, right? And Laden is hiding in some mountain. I don't know which it. I mean, it's right. And well, whatever. Okay. And the question may be saying, okay, it is known from intelligence from CIA. Okay, Bin Laden is active in this area. Okay, it's Bin Laden is running around this mountain area. Okay, you don't know where he is because he just every night he just moves to that place, right? If you don't like Bin Laden, you can be using the Iraq, right? Whatever you like, I don't care, right? But anyway, just that is the A, okay? And he's running around here, okay? So imagine you're the president of the United States, maybe Joe Biden, right? Or should we go back that time, right? Should be Bush, right? Junior Bush, okay? And then his defense secretary, I think it's M.Phil, right? And tell, okay, we fire a missile, okay? Of course, it's not atomic bomb, then atomic bomb is done, right? So just a missile and say end up here, okay? We bomb this area, B, okay? And then Bush wake up, okay? Okay, how likely that we hit him? Fair enough, right? Right? So he A running around and then the missile is just bomb this area, boom, okay? So the question is how likely we hit him, right? So it's just like, if we hit him, if the bomb is hitting, then it's just this area, right? Or maybe I use other color, right? Right? If it's here, then there's some probability hitting him, right? So what we want to ask is how likely is getting hit, right? So it's asking the probability A given B, right? So it will be, you get this area over the A intercept B, something like that. Okay. So anyway, if you don't like this, it's a little bit too funny example. So let's do some not so funny. Okay. Example like this. Okay. This example I think is a little bit more straightforward. So we already die. 1, 2, 3, 4, 5, 6, which we know very well. E is even, 2 to 4. Large is 4, 5, 6. Okay. And E intercept large means they are even number and large number only have 2 choices, is 4 and 6. All right, 2 is not there because intercept have the same element. So now the question is the following. Okay, now Roy die. I don't tell you what, but okay, let me give you a hint. Okay, it's large. Okay, it's large, but means that it must be 4, 5, 6. Right, but I don't tell you which one. Okay, so you now guess. Okay, how likely that? Oh, sorry, I tell you it's large. So okay, large, 5, 6, right? How likely that actually even? Okay. So the one way to do it is to think, okay, now the sample space is no longer 1 to 6. The sample space is 4, 5, 6. Right? It's you have fair, die is fair. Right? Was even. Only for this to make sense now is L, even is only 4 and 6. Right? So that means that is 2 outcome over possible is 3, so 2 over 3. So that is how you update, right? Basically, what you can do is to change the sample size, sample space, right? and to reflect updated, and then you do the calculation, that would be the same thing, right? But you can do this formula. The probability large is 3/6, right? The probability even and large is 2/6, is 2/3. Okay, so that's how you learn update. Okay, so this is crucial because this underlies how we learn things. Okay, this define, but before we do that, we learn if this is true, how likely this would happen is the difference is the intercept over what had happened. Okay, and if you like the law nature, you call the likelihood over the marginal. Okay, if you like this the terminology here. The denominator is called marginal, the numerator is called likelihood. Okay, but anyway, whatever you think, like this, right? Because now is now I told you E large had happened, so the sample size shrinks to this area, right? And only relevant is the purple part, right? So the purple over the whole circle, which is 2/3. Okay. Now let's look at this example, just apply it, right? If you have A is this, B like this, A intercept B like this, what is A given B? You just put in the formula there, right? So that would be just applied directly. So you would ask the similar question in your assignment. Okay. So for those who arrived late, just let you know that, I mean, we were able to finish this topic today, but the assignment is not effective on Wednesday. Okay, but anyway, that means that you have almost half a month to do it. Okay, I will release it later today. Okay. So once you have this conditional probability, you notice that a door open for you to calculate probability. Okay. Because you will learn the rule called multiplication rule. Okay, which is just reverse the definition. Okay, let us go back to here. Okay, you just multiply both sides for probability B, right? Then give you the multiplication rule, right? Because you just move it to the other side, right? To the left-hand side. Okay, you get this formula, and you swap the meaning of A and B, the same thing, right? So this is called multiplication rule. Or sometime when you learn advanced statistics class, they call conditioning. Okay, this is called conditional procedure. And later you will see why we need to do that through an example. This example is always found in a lot of things, right? Because you do things sequentially. Okay, for example, like this. Okay, if you do things independently, you don't need this, but you think do sequentially, the sample space change, then you can make your life easier by using this. So example like this. Okay, there's an urn, there's a boat. You have 6 balls. 3 of them is black, 3 of them is white. Okay, if you just draw one ball, that's very simple, right? Half likely that you draw a black, half likely to draw a white. Okay, nothing deep here. That's so simple. The question would be a little bit more tricky, okay? Because if you have to draw 2 balls consecutively without replacement, you draw 1 ball and then draw other one. Okay, that is a little bit tricky, right? Because once you draw a ball, the urn is different, right? Of course, you can list 6 balls here and then 6 balls there, and then you can draw the sample space and no problem, right? Then there should be 30 possible outcomes, right? Of course, you can do that. You can do all the table, then it should be fine. But if you draw 3 balls, 4 balls, 5 balls, then your life will be very miserable because the table will be very complicated, right? So now let's see how we can do it without planning everything, right? So how do we do that? So the first question is the probability. What is both ball black? Okay, how can we do that? Okay, the first ball is simple. What is probably the first ball is black? It's 1/2, right? Because it's 3/6, right? Because of you close the eye, right? There's 6 possible outcomes. You draw one of them, which is 3 chance, right? 3 outcome is favorable to that, right? 3/6. That is the first bullet point. That's called B1 is black, B2 is second ball is black, so it's 1/2. right? So now the next question is, okay, if I have drawn the first ball is black, what's likely the second ball is also black, right? Six balls, 3 black, 3 white. Now you take out 1 black. What you have is 2 black, 3 white, right? So what's likely you get a black is 2 out of 5. So 2/5. Is that clear for this one? Now with that, then make our life easier because black and black is just first black and second black given your first black. Then you just multiply, you're done, right? It's easy, right? Because you don't need to list out 30 outcomes and figure out which one is favorable, which one is not, right? So that means that this make your life easier, especially when you consider things are happen sequentially. There's a time dimension here, right? Because a lot of time we think about over time, right? Business application, finance application, right? The stock price go up and go down, go up and go down over time, right? Customer come in, no customer, come in, not come in, come in over time, right? We model things over time, we have to use this. There's no way to escape, right? It's very commonly used because when to describe, you can consider black is someone comes in, okay? White is no one comes in, right? That can be modeled this way, right? So that is how you would do the calculation, okay? And the other way to think about this is to draw a tree diagram, which is amazingly useful. I mean, probably you have learned it in your high school as well, okay? Because when they find an outcome, you can represent the outcome as a tree. Those who learn option pricing, that is standard binomial tree here, right? If you learn it there, it's just like the option pricing, how to get the best social model. Actually, learn in the algebra, they will tell you those. But it's not my class to tell you this, but that actually can extend easily to those kind of model, binomial pricing. But anyway, just make it our life easier, okay? The first draw, I mean, you have 2 possible choices, either black or white, which is equally likely because you have 3 black and 3 white. Okay. And now with second draw, depending on what you draw, you will change the composition of the urn, right? If you draw 1 black in the upper row, right, you would have 3 whites and 2 black, right? Because 1 black has been drawn. If you're drawing 1 white, then what you left is 2 whites and 3 black, right? And then the second ball is black and white, B2 and W2, depends on what you have drawn, right? Just can't number the ratio, right? It's 2/5 and 3/5, right? And so on, the same in the reverse order, right? Once you have that, then actually at the end, you have the end of the tree, the branches, right? Is B1, say the most upper one is B1 and B2. And how do you calculate probability? You just multiply along the branches. Why it works? Because this is basically the multiplication rule, right? Because look at the second branch, these numbers are conditional probability. Conditional on W1 or W2, right? This probability of W1, right? So basically you multiply along the branches, you get this particular outcome, okay? And if you want 2 black, will be 1/5, right? If we ask you the question, what's probability of 2 whites, then will be this guy, all right? And if I ask the question, what's probability 1 black and 1 white, okay? Then what's your take? It will be 6/10. Why? Because I said 1 black and 1 white. I didn't say 1 black then 1 white. If 1 black then 1 white, then it's 3/3. If 1 white then 1 black is 3/3 as well. But black and white means I can be black first and white and black. So be careful what I ask. Okay? Is it order or not order? Okay, have to be very careful. Okay, but you can simply add across branches if I ask you, right? Because each branch is mutually exclusive by drawing this way. So you can just add, right? Remember the addition rule. If mutually exclusive, right? The union of them, you just add them up because the intercept is 0. Okay. Don't worry about it. I mean, you have a lot of example exercise, then make sure that you understand. Okay. So here we got a little bit more tricky formula that's called total probability. Okay, it's just nothing but using the rule that we have so far. Okay, the first line is nothing. Probably A is A with B and A without B. Right? It's the same sentence, right? What happened tomorrow, right? Tomorrow will be with you and without you, right? Either way around, right? And with B can be decomposed in two parts, right? Using the multiplication rule is A given B times product B given B complement times product B complement. Okay, so that you will ask, okay, why we do that? Okay, very soon when we introduce the last most important rule, Bayes' theorem, we'll use this. Okay, don't worry. We'll use this all the time, so don't worry. This part, I mean, so far we see so many formula, right? But remember, our class is open book. Okay, no need to remember all the formula. Just understand what's going on there, at least in plain English. Okay, you should convince yourself why this is true. Okay, I mean the math derivation, which I skip anyway, right? Because I put it in the black. It's not important, but you're able to explain why this is true, right? Because say, suppose the first line, A, right, must be either A with B, A without B, right? That's easy, right? And this is just a definition, right? A and B is B happen and B after given B happen and A will happen, right? So all this you can explain in English. It's very important, right? Because I guess the problem of learning math is not about how to derive the math itself, right? It's an important skill, but the problem is you easily forget those kind of stuff. But the problem would be how you're able to explain yourself to your manager, to your customer who are not math oriented, right? He has to know what's going on to explain why your calculation works, right? Or have to convince you this is right? Because these days now, AI, internet is so convenient, right? There's no point to remember all the formula anyway. You don't know how to apply. Okay. Now this example, okay. Now I think this is an interesting one, okay. Again, drawing balls. Well, probably you may say, okay, why so boring we draw balls? Because anyway, because this is, I think, mathematicians like magic, so that's why they keep drawing balls. But I have no idea why they have used balls, but that's fine. Now we have a bat called A with 4 balls. It's 4 green and 4 white and 1 green. And a bat called bat B with 1 white and 1 green. Okay. Yes. So now the question is, I close my eye. Okay. I don't know which bat I'm drawing. Okay. The nature decide, right? You can imagine this is white is maybe price goes up, green maybe price goes down, right? Nature decide bet A is a good times, bet B is a bad time, right? Good time more like go up than go down. If bad, it's just nothing, right? Or you can imagine a firm, they may have scientific discovery, breakthrough in technology that end into bad A, or there's nothing discovered, go to bad B, right? Then the good times, stock price goes up, right? 4 or 5 times, stock price go up and go down with green, this red. If nothing happened, normal time go up and go down is equally likely. So, I mean, this bad can be translated into whatever you like, right? But that would be the thing, right? So it's sort of random, right? Close my eye and close it, and then choose a bat, and I close my eye again, and the bat I play a ball. Okay, there are 2 random process goes on here. First, I close my eye, choose a bat, and once I choose a bat, which I don't know which bat I'm doing, but I draw a ball there. I look at the color. That's the only thing I do. Okay, I don't know which bat I'm drawing. I don't know which ball I'm drawing. Okay, but I know the color of the ball at the end. Okay, and the question is, okay, how likely that it's a white ball? Okay, there's 2 processes, but I don't know which one is being drawn. Okay, so because it's a sequential process, as I said, you can decompose it. Okay, white from A and white from B, because A and B are partition, right? Mutually exclusive and exhaustive, right? So white with A or white with B. And white with A will be, given A, you draw white and time poly A, and white under B time poly B, right? This is called conditionaling, okay? Or we apply the multiplication rule. And because to close my eye, ball A is 1/2, ball B, sorry, bet B is, bet A is 1/2, bet B is 1/2, right? And then how likely you have a white ball when under A is 4/5? How likely you have white under bet B is 1/2 as well? So just calculation is 65% is a white ball. Okay. Now, of course, probably you will ask, okay, why I care about this? The question is, we will do it soon, is if we have white ball, how likely from bet A? That's a question. Why? Because it's important, because as I said, we only know the stock price go up and go down. Then we want to infer whether it's a good news for the firm. Then we can do investment. That's how you learn information update. We will do it soon, but that's the idea, right? Because remember, A and B can be considered as a breakthrough in this research, and B is nothing happened, right? White means go up the price, green means flat, right? What we want to know is, okay, I see the price goes up. We want to infer, actually there is a discovery in the firm. If high enough, then I want to buy, right? If not, then just, okay, that's fine. There's nothing new there, right? That's how we learn, right? And that is underlie all the fundamental analysis, technical analysis, all the pricing you like, right? You see something happen in the market, update, you learn. Or same as, or you do accounting or auditing, you see something happen, okay? Something unusual, update your belief, and then you decide whether to contact Mr. King, right? And the same for every aspect in your life, right? When a couple, right, suspect the other partner is dishonest, right? You keep observing evidence, right? Keep update until the probability passing through your threshold, then you try to do something, right? The same thing happens, right? Or later you see the medical test, right? And you go to the doctor, and the doctor says, okay, maybe there's something, and then do the test. And okay, not enough, do another one, and keep doing until you get satisfied, right? That's what happened in the COVID time, right? The government said, okay, do one test, okay, do another one, and do another one, right? Until 14 days you're out of the quarantine hotel. Right? Same idea. Okay. Now just go back to here. We want to draw the tree diagram, because the tree diagram, I think, is the most useful thing to visualize what's going on there, right? Because this is how you can imagine this is like the nature decide the stock going up to go down, A or B, right? If A bet is like 4 up and 1 down, right? 4 white and 1 green, right? And then the probability there, and then if B, then it up and down, right? White and green, like this way. Okay, so everything can be done placed in financial market or whatever you can imagine. That's not something terrible, right? So probably the white ball is being drawn. It just you add up the first branch and the third branch, right? If you want to green, then would be the second branch and the last branch, right? Because favorable to the white, favorable to the green. Okay. So let me quickly talk about this, because after that we have the base theorem, which is the most exciting one. But before that, let's connect this very simple idea. There's nothing very deep here. It's very simple definition. Okay. This definition is called independence. Okay, means they're unrelated, right? Unrelated. And the definition of independence means that telling you one thing doesn't change my probability. All right. Say the probability A and B are independent, telling me B happened doesn't change my assessment of A. Telling B might happen doesn't change my assessment of B. The intersect is just multiply. Okay, there's nothing but just the definition of multiplication rule. Okay, because A given B is same as A, right? So 3 of them are equivalent. You don't need 3 of them. Anyway, 1 of them is fine. Okay, you can prove it at the same thing. Okay? Say suppose rolling a coin and rolling a die are independent, right? Telling you that what is the phase of the coin tossing have no impact on the number of die facing up, right? And probably you know recent news, probably if you don't read the news, right? The recent Mark 6, right? The last 2 one, mark 6 is 6 number there, lottery. If you get 6 number, then you get a huge money. And turn out to be very interesting cases. 5 or 6 number for consecutive 2 lottery are the same. Okay, which is surprising. People suspect there's something, but the physics, professor in our school actually explained it's not possible because it's a chaos system. As long as the initial condition is not the same, then you can't really repeat the same thing. But anyway, it's independent, right? Because these Mark 6 lottery, right, have different setup, very different way to do things, and the second one is very different. So telling you what's outcome the first one, the second one is not the same. Okay, and independence is very important because you can imagine people in the casino would think otherwise. Okay, there's a very famous called hot hand fallacy. Is would think just like the basketball, right? You would think if one guy shoot in and he keeps shooting in, there is some mysterious force behind. Okay, can help. Or if a casino is a big and small, right? If you keep going big on 10 times, you go to big again, it's big, right? It's more likely to be big. Of course, if you think that the die is not fair, then there's some reason. But you think the die is fair, there's no reason that would happen, right? And that is why it's independent. Will make us telling us that what happened in the past, what happened is no meaning, right? That's why some people believe in stock market is efficient. Okay, they think, okay, what the price now has already reflected all the information that has been public or what has been known. So all the price history has no meaning at all. Okay, so all the technical analysis is not useful. Okay, that's what the efficient market hypothesis. Then if you believe that's the case, the market is efficient. Okay, then the price movement about the future is in the past. So telling you what happened has no meaning. Okay, right? And of course, many people believe, as I believe as well, is the market is almost efficient. Okay, 99.99% efficient, but there's still some chance you can make money because it's not that small chance you can enough to make the money because market is not efficient by itself, right? Have to move by someone. So if you're the one who moved, then done. Okay, you still can make money. That's how people can still make money because to the majority of people is independent, right? But have to someone who make it independent, right? If the one you are, then you can make money, right? Okay, this is a question, very simple question with a break after that. So if two in system, I tell you event A is 0.6, event B is 0.5, A intercept B is 0.25. Yeah, then are they independent? Simple to check. Do the multiplication. If the multiplication is same as the intercept, yes. Otherwise, no. Okay. So that would be easy to check. Just a minor remark. If you draw a ball from an urn, okay, you put it back, then the second draw should be independent. Okay. If you don't put back, it's not independent. That is very simple, right? I don't think that's require extra explanation. And one thing that mutually exclusive, okay, means not independent, right? Because if I tell you one thing would happen, the other is not, right? So I tell you something, that is not mutually exclusive, and dependence are mutually exclusive, pun intended, but that is what it means, right? So independent means that telling you one thing happened or not, absolutely tell you nothing about the other. They're independent, right? And the law of things is independent, right? But of course, you may pretty argue that there's a butterfly effect, right? With a butterfly, flip its wing here may affect something far away. Okay, that's fine. But we can safely ignore those because it's too complicated for our mind to think about that anyway. So we can safely think if many of our things are independent by assumption. But anyway, if you believe in karma, then probably that things are not independent, right? In the world, maybe that afterlife as well. But anyway, we don't talk about philosophy. But after the break, we talk about this most important rule that probably you should remember for the rest of the class. If you forget everything, okay, from our class. And if you still want to show other people that you have learned this class, one is this base rule. Second is regression. Okay, this is two things that you should able to tell others, because normal, but this is the new thing that you learn in the college level, right? Anyway, that's a break of 15 minutes. In the meantime, you can do the U reply. Tell me how fast or how slow I'm going. I see you soon. 15 minutes time. I walk around to talk to you, and you can tell me how fast, how slow I am.
Yeah, when you're talking about probability tree, I want to learn Black-Scholes model. One of the best ways to start to like put yourself out there is to build a Black-Scholes model on
But you can start by
yeah.
you can start with that and
Yeah, because I'm just learning how to write Hello World first, but
oh yeah, but you will do that. It's not like allocation. Exercise. But you do a nice numerical function. But I see
I'm lucky. They didn't even send like a thing saying like you're good. They go, I just last night I saw that I got the DOTE to 11 find out my screen.
Yeah, they are actually not target tracking 2 days in the first one. Sometimes it's like, oh,
Yeah, no,
I more email than you want. It's not good. You have to go to every channel. It's not really, it's really.
the probability is random.
Yeah, randomly they can go to, it's not uniformly data, or uniformly is not. It's pretty much like random. 1.5 time to get it.
No, yeah, I noticed that actually something I get like 6 emails from CHK from like all the different departments. Like said sometimes don't they like flash or whatever.
Yeah.
But hey, that's
Good, good. Welcome to the house.
That's it.
Time we can do it all and then we go all over the world.
So maybe we can start looking at your comment. See what happened. Okay, it's good that we have 34 of you have joined. Let's see what happened. Yes, we have talked about some deep theory, but don't worry, the base is the best we can go. Okay, although we talk about some combination permutation thing, but that is only used. I need that because I talk about binomial distribution, but there's some counting exercise, but we do need some basic understanding, right? Because we need to understand what's learning, right? That is underlying a lot of things we do in daily life, finance, how we update, right? That is very normal thing we do. It's nothing very surprising here. Independence. Independent means they're unrelated at all. Telling you one thing doesn't tell the other, right? For example, people ask me, right? Suppose I want to assess the probability that someone cheated in final exam, right? If you tell me this morning he has a breakfast, doesn't change my assessment, right? There's no meaning at all, right? Or last night he go to casino, last night he go disco, or last night he drank a beer, irrelevant, right? Or independent usually is by assumption. We think about what's going on there, right? For example, the question is, I ask you toss a coin. You know, if the coin is fair, the probability is 1/2 is head, 1/2 is a tail. The question now goes, if I ask tossing a coin twice, okay, suppose your hand is fair, that means independent. What's the probability you get 2 heads? Okay, then it's simple. The first head is 1/2, the second head is 1/2, right? So it's 1/2 times 1/2. It's 1/4, right? And that's independent, right? Independent means they are unrelated, okay? Telling you what happened or not doesn't tell you the other, okay? So I hope that would make sense. That is because why we need that is throughout the semester, when we draw sample, we assume each sample is drawn independently. That's why we look at the first observation we look at. So suppose I want to know the income of people in Hong Kong. I randomly pick up a guy or person from the street. He tells me a number. And then go to the second guy, a number again. What we assume is each observation independent. If not, then our life is much more difficult. We need to do something else. But independent is need in that purpose. Okay. And how do you make sure that is by some sophisticated process to make sure that data collection follow independence. Okay. And independence is like as a faith. Okay. Whether it's not, I don't know, right? But there's something that we try to make sure that more or less independent. Okay. And by doing so, we make sure that our data analysis is simple. If not independent, our life is very difficult. Okay. I hope that try to give you an idea why we need them and when to use it. 2 and 2. I don't know. I'm hungry. No way, it's 2:30. Why are you still hungry? Make sure that you don't worry. Oh, Zhao Gong. I mean this is the sleeping god. Okay, so one is hungry, one is sleepy. Yeah, if you're hungry, then you are not sleepy. I would say these are what? Mutually exclusive, right? I tell you I'm hungry, Zhao Gong cannot find me, right? If Zhao Gong is finding me, I can't be hungry, right? Then they're not independent. Okay, this is a good example, I guess, right? Because, right, I tell you I'm hungry, then Zhao Gong will not be near me. If Zhao Gong is near me, then I can't be hungry. Okay, so I hope that makes sense, right? If I say I'm hungry last year and hungry today, is independent, right? I think more or less independent, right? Maybe some relation, long distance pass, but it's rather independent, right? Yeah, thank you. Oh, you're still hungry. Yeah, okay. So I can tell you I didn't eat as well. So same as you do. I mean, I didn't eat anyway. So it's independent, right? You didn't eat and I didn't eat. It's independent decision, but that happened. I want to learn more probability tree and black social model. Yes, but that will cover in the 3000 finance class or 4000 finance class. I don't want to teach them this stuff, but you go to math, linear algebra application, they also talk about this. But I mean, I don't have time to cover all this thing, but you can see the idea is similar. But say binomial probability tree is just like this. I mean, just very briefly, right? It's just saying that we're similar to this one, just to make sure that I just don't completely hand wave there. they will be looking at this a lot of time, say European option. At the end, you exercise and then you calculate the value of the stock, right? And then go back to calculate what should the stock should value. So this is the model. And Black-Scholes is a little bit more general. It's just like the underlying stock is following a normal distribution, so on and so forth. But there will be something you learn in 4,000 class or 3,000 classes. I'm sorry, I can't really do that. You can, but that being said, you can look at Wikipedia. AI is easy to find the solution there. But if you have time, I don't think we have time, but you can take a look at that. Well, that is the purpose of exercise, to force you to work on the apply it. Like I told some of you, it's just like swimming, like the math. I tell you the style, how to swim, the stroke, how to do it. You can never learn it without actually put the water, right? So that's why I force you to do your assignment. You should also do your multiple choice quiz, which you don't fully follow, right? It's not credit bearing. And you have to work on the problem as a project. So make sure you work, right? I mean, if you don't work, you never learn from this class. Okay, same all the math classes, right? For other classes, you may not even actually have to work, but for all the math classes, as far as I understand, unless you're super genius, okay, you can learn by just looking. Otherwise, you have to actually work on some problem. That's why you can see all the math textbook, right? All examples, example exercise, right? So I mean that it's not surprising here. Yeah, good. Quickly. Oh, still some people think it's Friday. Oh yeah, that's good. I think it's a good distribution. Conditional probability multiplication rule, yes. Given A times, yes. Probability rule is determine probability. Yeah. Let's break down the rule. Complement. Oh, I'm glad to understand, but you will understand only if you do more exercise. Then you understand what's going on there. So I do recommend, even you have opportunity to copy from others, don't copy. Even though you really want to look at others, make sure you understand what's going on. Okay. If you don't, please ask TA. Okay. I mean, that is the opportunity to learn. The probability is likely over marginal. Yeah, that's the yeah. Okay. Good. I think you got it right. So most of you get okay with the speed. Most of you is okay following. What breakfast do I have? I have an egg, and some pears and some apple, and that's pretty much. I don't have carbohydrates because you can see I'm overweight a little bit, so I have to keep my carbohydrate low. But you guys are young, so eat more carbohydrates and protein, right? Quite sleepy. Yes, avoid carbohydrate in the afternoon if you want to, or have a tea or coffee would be a moderate amount will keep you awake. And one of the good things in Hong Kong is you can have chewing gums. Try to have that when you are sleepy, or you have some candy in your mouth that make you a little bit better. Manchester United, is there something happening? Is it going to downgrade or what? I don't know. I'm not following the UK soccer. Let's see if this is the one that. Is it a trap? Let's see. I guess a trap again, but let's fall in the trap. Oh, this one. Oh, I think this is a very funny. Can I have the sound? I don't know.
Galvanized steel structure, open kitchen, big living room, big wardrobe, big bedroom, giant separation bathroom, triple cleansed windows. Electric curtains, if Habibi like, cut me. Hello, boss.
Oh.
Hello, Habibi.
Okay, I think this is a good joke, I guess. Oh, I think that's a. Oh. I think this is the explanation of what's going on. Oh, that's fun. Oh, congratulations. If you win some money, then can buy us some drinks. Oh, there's another one. Why? It's very difficult to copy the link. No? No, not this one. I see. No way I can copy this guy. Or maybe I copy the whole thing. Yeah. It's very difficult to. Oh, yeah, this is a good one. This is how I do it. What's this? Oh, sorry. I think we know what's going on for the rest. So it just keeps screaming for no reason. But I hope make sure that those of you who are sleepy can stay awake a little bit. Yes, please think of a good one to share. I think one of the most funny part of this class is someone shared a nice thing together. Right? I think it's a good one. Yeah. Well, whether you should, first I would say, go to casino, the gambling is unfair. So it means that if you gamble long enough, you lose money, no matter what you do. Okay? If you are smart enough, you gamble, you leave, then it's okay. But the problem is no people can control himself that easily unless you are well trained. So in general, I would advise again gambling, right? Because but that being said, I mean, financial market is not too much different from gambling in that sense, but you can control more easily. But yeah, I think that would be the thing. But if you are opening casino, then yes. Okay. If you are the gambler, probably not. I hope I answered the question. Now let me give you the final one. This is the most useful. As I said, the most useful formula here is the Bayes rule. Okay, that is so often used that you don't even aware it. Actually, all your medical doctor you match every day he do this. Okay, actually every day in your mind you do this in your head. Okay, and let's see what does that mean. Okay, probably A is what we have initially. Okay, and I talk about some evidence B. Okay, and now what we want is given B had happened. Okay, you know B happened. What's probably A? Okay, so how do you do that? Okay, it's by this formula. Okay, before you have A, now you have A given B, and you multiply by some number divided by some number. Okay, and this formula by itself actually need no memory because then use the multiplication rule. The numerator is just for A and B, A intercept B. So the numerator is nothing new, right? It's just the conditional probability definition, right? That's how I remember this formula. I never remember. I just say this is a conditional probability and then just divide it. Okay? And what does that mean here? It's kind of weird, right? Is A, okay, I just time something, divide by something. How can this be the miracle formula that I need to remember? Or I need to understand, okay? Now, what's going on here is why you update it is A, right? And with the evidence of B, then how you update A, right? So first is why you would multiply probably B intersect A, right? And that thing is like, if A is true, what happened you see B, right? Remember B has already been true, right? Is a adjustment to the A, right? Because I know B had happened, right? Right? If A is true, if B is going to go in 9, then is to go adjust upward, right? If A is true, right, B would happen, right? Then this is directly related. That's when you multiply, right? If this probability is high, right, then A is more likely, right? Because I want to find A actually happen. And why do you want B? Because if B happen in general, right, then that's actually telling me the information is content is very low, right? Adjustment information content. Okay. So the formula by proof it like is very simple. It's just like usually people would call this is prior times the likelihood over the marginal. Okay. But this is how people in medical school would teach. Okay. And they would call different name, but this is how they teach it. And they would say initial belief before evidence times the probability of evidence under the belief over the probability of evidence. Okay, is the probability updated belief. Okay, so it's probably still very abstract. Okay, very abstract. Okay, let us apply it to the real context. Understand, because it's. I would say when I first learned this, I said, what is this? I mean, nothing. Why is it so miracle formula? Okay, look at the example, they understand. Okay, that will make you easily understand what's going on. Okay, you can guess disapprove, but we'll skip it. Look at the tree diagram, probably will give you a better idea. Okay. Now, the first node is A and A complement, right? The world can be considered as the nature design is A or A complement, which we don't know. Okay, just like close the eye, draw the bat, same idea. Okay. And under A, right, B would happen, go up, B would not happen, go down, right? So that would be two outcome here. If under A complement, there would be and B complement. So that would be 4 possible cases in this world, right? We don't know which one is going to be true, okay? Now, you are told that B is true or you observe something B, okay? That means that only the red branches are relevant, right? Because you know B had happened. B complement is not, right? So the sample space only relevant is 1 and the 3rd branches, okay? You want to know the probability A happened. That's very simple. Just the first branches over the sum of the 2 branches. 1 over 1 plus 3. That's probability. That's the base rule. That is a base rule. There's nothing new, right? Because the sample space shrink, right? So the upper hand part is right this one, and the below part, right? Add up together, it's just probability B, right? That is the total probability rule, right? There's nothing new here. Okay, probably you still think it's very abstract. Don't worry, we'll give you a concrete example, then you will see. Okay, a very concrete example here. Now, and then you give it application. So the first example here is like this. It's a bad A, 4 white and 1 green, and bad B, 1 white, 1 green. Same example as we have seen. Okay, and close my eye and choose it. Okay, and now I have drawn a white ball. Okay, it's going to be A or B. Bet actually have been drawn. Okay, and even without calculation, you know the answer. Should be A, right? If you try to bet your money on, who will say B? Who will say A? I think it's A, right? Because A has more whites, right? That is your bet if you want to put the money. Okay. Why? Because under A, Y is 4/5. Under B, Y is 1/2. And A and B equally likely, right? You draw the eye. A and B equally likely. Okay. Now let's calculate that. What's probability of A given white? Okay. So what I want to calculate is like this. I want to calculate this. Given I've shown a white, what's A, what's B? All right? Then I can know how to do it. Remember, as a metaphor, white is stock price goes up, B stock price goes down, A is scientific breakthrough, B has nothing. Right? I want to know, given the price has gone up, how likely that actually the company has breakthrough its own technology. Okay? So I want to know that. So the first question is nothing new here, is what we have learned before, right? Is white is applying the total probability rule. This we calculate that. If you still unsure, this is the formula we have already calculated here back. Okay? In the example in the slide 54 here. Okay? So I'm not going to repeat myself. This will be the answer. Is 13/20. Okay? So white ball is more likely as we expect, right? It's not 10/20, right? If equal likely, it's 10/20. But slightly more chance to have a white ball than green, right? Because A has more white than green, right? And B is equally green or white. Okay. Now we will apply the base rule, okay? Which is not surprising. A given B, apply the base rule. First thing is numerator. You flip it, right? A given white is Y given A times A over what you conditional on, white. That's how I remember it. Just flip it and multiply it and divided by what you conditional on, right? So the first one, W given A, right, is 4/5. A is 1/2. Y is 13/20. That is 8/15, right? It's 5/13, right? So if you have a white here, we will be 8 out of 13 times. You think it's A, otherwise B. Okay. So you would think that's more likely that actually the company has breakthrough, right? And you can keep this exercise again if you see the stock price go up and go down. Okay. That is a famous model called sequential trade model if you learn the trade theory. But I'm not going to talk about this kind of financial trading model, but that would be how price being adjusted. Okay. Now, probably you would think this is too abstract. Why care about white ball, black ball? Okay. I don't care about green ball, white ball. I don't care about balls. All I care about is my health. Okay. I care how, right? Now it's COVID is over, right? But if you read the news, there's a new kind of flu is coming that is going to be infectious. Okay, let's see this example. And I'll make the simple case. 40% of population is infected. Okay, I mean you can change the number, but that's an imperfect medical test. I do the example because of COVID, which probably would fit the idea. Okay. Now the bullet point there have to read carefully. Okay. It read the following: and infect the person has positive result with bullet point A. So given a guy has disease, if you give a test there, 80% that's correct. So accuracy is 80%. Okay. So there will be false negative, 20%. Right? True positive is 80%. False positive is 20%. Sorry, false negative. False negative 20%, right? The positive guy, they have a negative, right? So it's false negative is 20%. The second one is uninfected person has positive is 0.4, which means that this false positive is 40%, right? The guy has no disease, but 40% has a disease. Okay? It's wrong, it's inaccurate. So that means that if the guy is uninfected, give negative result, 60%. Okay, so that is the setup. Okay, so if you go to medical school, this is what they will learn. Okay, probably this is the maximum they will learn for the statistics. I mean, of course, they will learn regression and ANOVA, but that would be the most difficult part for them. I used to have medical students sitting behind, but anyway, I don't know whether we still have anything. We don't check everyone, but that would be the thing. Okay. Now, let's do the following. The question is, okay, that's often asked by the doctor, right? I send the patient to a lab. He come back with positive result. Okay, the question would be, how likely is he's being infected? Okay, should I send him to hospital? Okay, or should I quarantine him? Whatever action I'm going to take, right? Have to base on that, right? Or in general, this is something that I want to make a surgery, right? Have to do tests and see whether actually he has a disease, and then you do the surgery or not, right? And so the question is like this. Okay, let's make our life easy. A is the event being infected. B has a positive result. Okay. And the first way to do whatever you do, make the notation A and B, and then write down what the questions give you in terms of symbol. Okay. Okay. Let me repeat. The first step is make some notation A and B, okay, to simplify your expression, and then convert what you observed to given material in notation. First is probably A is 0.4. Why? 40% of the population infected. Okay. Second, probably B given A is 0.8, which is given by the first bullet point, right? Given that he is infected, 80% he get positive result. And not infected is A complement, right? Positive result is 0.4. Okay. So the question is find A given B, right? Given he has positive result, how likely that he's infected? Okay, so this is a very useful thing, right? Because we often give tests, right? That's why I said this is the scientific discovery process, right? And given the new information, how we should change our understanding of what happening in the world, right? All the system, all the algorithm trading model, how a accounting decision, how the auditor changed the decision is like this. Everyone is like this. Either you do it implicitly or you do it mathematically, all like this. Okay. And of course, those of you who learn machine learning, artificial intelligence, this Bayes rule is one way that people learn. Okay? How the machine, you can ask machine to learn in this way. Okay. Of course, this way may not be, it's complicated. So sometimes they have a machine learning, they have called non-Bayesian learning, which may be faster, but this is the most rational we can think of. Okay. Now, how can we do that? Okay. Not complicated. Okay, what we do is to find what we can find, right? That's how you solve the problem, right? The same, you have all the symbols, invoke all the theorem, apply there, and then figure out what's going on. Okay, first, what we do is apply complement rule. Probability A is 0.4. A complement must be 0.6 because add to 1, right? Either one guy had disease or no disease. Okay, first. Second is calculate probability that that guy has positive result. Why? Because that will be the denominator of the Bayes rule, right? Because I want to find this. The Bayes rule tells you this guy, right? So what I want is I have the numerator, I want the denominator, and I want this guy, right? This guy is given by the question. This guy, the question as well, or you want this guy, right? Only thing is unknown is denominator according to Bayes rule. Okay, how to find denominator? We apply the total probability rule. B is B under A and B under A complement. Okay, when we have positive test result, is positive test result under a infected guy or under uninfected guy, right? A complement and A, right? So it's adding, right? Because the two things, right? You say add together. Now, and the first one, B and A, right? You can use the multiplication rule to divide them is B given A times A, right? Same as B given A complement has A complement. Okay. And then, well, that shouldn't surprise you. This guy is already given by the question, right? If your disease, 80% positive, right? And this is given by the question, 40% population is infected. And then if you have no disease, you are infected is 40%. right? In the population, 40% is infected, 60% is not, right? So that is get up to 0.56. Okay, now it's done because the fraction here is everything there, right? So you can just calculate. No, not surprisingly, or maybe not, even though the test is 80% correct, right? If a disease, you have 80% that is you have infected, right? Because of the false positive, right? Because even though you don't have disease, you're 40% that you are going to be there. Turn out that even though you get a positive test, you don't need to worry too much, right? You just similar toss a coin, right? But you're running from the unconditional 40% to 57, right? Slightly jump, okay? And probably if you are the doctor, you would not go to send him to the hospital yet. You would do is ask him to do again, okay? And then you can repeat this process, which is beyond, probably should be beyond the difficulty of our class. Actually, you can apply the base rule again, okay? The idea is this number the same. You just put the number here and repeat this, you get the new number, okay? But that will be, repeating applying base rule will be beyond our scope. But you can actually repeat apply the same formula and keep up. They actually can see go up from 4, right? From 0.4 up this guy, okay? You can replay this one, you can go up, okay? Then you can decide how many times you go up to make sure that it's all right, okay? But I will not ask you to repeat apply base rule. The maximum is just once, okay? But you can easily repeat this process, right? That's what the doctor do, right? Come back, positive result, yeah, okay. Do it again, do it again, right? Until he's satisfied, okay? But repeat applying will be beyond the scope, but shouldn't be difficult for you to think. Actually, this can be repeat and repeat. That's how learning being done, okay? Because doctor keep learning, right? Same thing here, okay? So just to look at the tree diagram again, right? Infected or not, I don't know. Nature design, right? The text positive, negative, right? It's nature design, right? The question is, I have a guy who is having positive test result, whether it's infected, right? So positive result is only the first branch and the third branch, right? Because negative result will be the second and the fourth, right? So I have positive result, then the black branch is unrelated, only the red relevant, right? Then the question is, positive result, how likely that he's infected, which is the first branch over the string, the sample size is first and third, right? So the first branch is the numerator, the denominator is the first plus the third, okay? So let's apply this rule to a guy for a negative result, okay? And then by complement rule, okay, you can calculate B complement is 0.44, right? Because B is 0.56, right? Okay. And then you can calculate B complement negative result given infected is 0.2, right? This is a false negative, right? And then you can apply the base rule again, flip it, and do all the calculation, right? So if you have negative result, the disease is very low, right? So in this case, negative is a good thing, right? Positive doesn't mean a lot. So your negative, more or less, you're safe, right? But positive, yeah, still not that bad, okay? All right. So that is a lot of times same as what exam we do, right? All the exams is like, if you fail, then you are very bad. If you pass, it doesn't mean it means something, doesn't mean a lot, right? But that is the idea. So as I said, how you learn, right? if 0.4 originally, right? Now your positive result, you will rise to 0.57. If you are negative, then you have 0.1819, right? Update it. If you can do another test, you can do the same procedure. Just replace 0.4 by this number, right? And everything will be just done according to which realization of the outcome, right? Is that okay? So I'm pretty sure that that is something that you would not feel easy once you read it, because you actually have to work on the assignment problem, stumble on it, and then figure out how actually the formula, which one to apply to what. I mean, there's no replacing that unless I hold your hand and do exercise. Okay, just do it. I give you at least 2 weeks to do it, so you should have enough time to think about the problem, how to apply the formula there to the B.A.s. Okay. So there's some counting, but I don't want to continue because I will do it on Wednesday as well, because I said I want to give you 5 minutes earlier off. So now is because I 1 over time, so I just compensated this one. So Wednesday we come back, then we can do this, but I will list the assignment earlier, probably except the last question you can't do, but you can do the rest. Okay, I see you on Wednesday. Have a nice day. I stay around to answer any question you might have.